Math 9. Today we are going to be looking at Chapter 7, Lesson 7.6, Rotations and Rotational Symmetry. So what we're actually going to be doing in this unit is demonstrating an understanding of line symmetry and rotational symmetry. So last class we looked at line symmetry, and that just meant that if I looked at an object, could I fold this object and match it up? So if I were to fold these sides so they connect, the pink would land on the pink, the dark blue on the dark blue, etc. So you would be able to say that there is line symmetry. Today we are going to be looking at similar things, but we are looking at rotational symmetry, which is really just asking a question like, if I had a shape and I were to spin it, how many times could it land exactly how it began? Okay, so a shape has rotational symmetry when it can be turned less than 360 degrees about its center to match itself exactly. So if it only matches when it's returned to its original shape, we say that there is no rotational symmetry. So the number of matches in a complete turn is called the order of rotation. So here's an example of what we're talking about. If I were to spin this star around itself along the center. And so I have trace paper to kind of show you guys exactly what it is that I am talking about. Though at home you guys may not have access to this, so if you have just plain white paper that you can use to trace, or you're just going to actually have to practice your visualization skills. So if I were to spin this paper to see how many times this would land exactly on itself, I would say that it matches here. So 1 time, 2 times, 3, 4, and 5 back to the original. Okay, so if I have a shape like this, when my top point matched here, 1, 2, 3, 4, 5, it went and matched all of those times. So I would say that it has a rotational symmetry of order 5. So I do count that last turn to where it returned to in my count. Okay, so 1, 2, 3, 4, 5 in total. Okay, so that is the order of rotational. How many times can you spin it and it lands on itself? So if you had these objects here, find the order of rotational symmetry. How many times would I have to spin it? So 1, this line right here would match once, twice, 3, 4 times when it's back at the original, so you can picture it spinning. So the shape and its tracing would match 4 times. So the shape has rotational symmetry of order 4. Okay, if I looked at this one, so I'm going to say that this is like my original line. Okay, so if I were to spin this, this line would match up down here. So once, over here, twice, and then back where I began, 3. So the shape would have a rotational symmetry of order 3. Second half of this lesson is to find the angle of rotation. So the smallest angle you need to turn for 2 shapes to match is called the angle of rotation. And this is the formula that you are going to use every time. 360, because that's how much is in a full turn, divided by the order of rotation, how many times it spins and lands on itself. So if I went back to this first example, I would be saying that it is 360, and I am dividing 360 by 4 because it spins on itself 4 times, which would tell me that I have an angle of rotation of 90 degrees. So every 90 degrees, it lines up and lands on itself. For the second one, I would be saying 360 divided by my order, which was 3, which would give me 120 degrees. So that means that to turn from this to here, I had to move it 120 degrees. Find the angle of rotational symmetry for each shape. So if you want to pause this video and go ahead and try this out, you're welcome to do so. If you want to just follow along with me, you're free to do that as well. So find the angle of rotational symmetry for each shape. The shape and its tracing match. So if this were to be spun, it does not meet there, but it would match down here. So 1 and back at the original 2 times. So the order of rotation is 2. So I'm going to say 360 divided by 2, which equals 180. So the angle of rotation symmetry is 180 degrees. For the second shape, if I say this is my original, this is going to match here for 1, here for 2, and back where I began for 3. So it would match 3 times. So the order of rotation is 3. Angle of rotation symmetry is going to be 360 divided by the order. So 360 divided by 3 is 120. So the angle of rotation symmetry is 120 degrees. Okay, again, what you need to remember is that shapes that need a complete turn to match, again, do not have rotational symmetry. So that does not count. Okay, those of you guys who have this at home will see that you have this little section. Now, due to how we are learning online and the chance that you guys do not have trace paper or protractors or isometric paper that can help you do these things, this is actually going to be something that we're going to put to the side. And once we're back in school, we're going to take a day and do a starter to work through this kind of problem. So you can just skip this one today, and don't worry, it's not going to come back in the rest of this unit. Okay, so if we continue to what it is that you guys are doing, find the order of rotational symmetry for each shape. So how many times would this object land on itself if I were to spin it? So if this is my original, it'd match 1, 2, 3, 4. So the shape and its image match 4 times. So the shape has rotational symmetry of order 4. For B, if I say that this point is my original, it will match 1, 2, 3, 4, 5 times. So the shape has rotational symmetry of order 5. Okay, second part of this one has us looking at the angle of rotational symmetry for each of these objects. So my formula does not change. The order of rotation for A was 4. I am saying 360 divided by 4, which gives me 90 degrees. So the angle of rotational symmetry is 90. Okay, for question B, the order that we found was 5. So I'm saying 360 divided by 5, which is going to give me 72. So it is 72 degrees. And the last question we have here is, does this shape have rotational symmetry? So do you think that I would be able to spin this shape around itself, like around this point that is there, and it would land exactly on itself? So if you're not sure, I'm going to actually show this one with an image so that you can see. Okay, so this is where I'm turning it around and I spin it. You will see that it's not lining up, still not lining up, still doesn't line up nice. Okay, and then it lines up right where I began. Okay, so the only time it lines up is where it began. So if it only happens once and where it began, then we are saying that it does not have rotational symmetry. Okay, so does it have rotational symmetry? No. Okay, so please remember, if it only happens once, we say it is no. There is no order of rotational symmetry if it's only once. Here are some practice questions for you guys to be doing in your text. If you have any questions or concerns, please make sure that you are letting me know. Have a great day.